Okay, question number 17 on page 559. First part, it tells us it's a stone being swung in a vertical circle, and it wants to know what's the tension at the top for part A and the tension in the bottom for part B. So at the top, we have Fg acting down and Ft also acting down, both towards the middle of the circle. So when we do, the sum of the forces is equal to mv squared over r. Both of these are going to be positive. So it's going to be Ft plus Fg, because they're both going to the middle of the circle, equals mv squared over r. You're solving for Ft, so take the Fg over to the other side, it becomes minus. So Ft is equal to, it tells us the mass is 0.284 kilograms. The speed was 12.4 meters per second, and that gets squared, over 0.85 of a meter. And then you're going to take away from that the 0.84 kilograms times 9.81 meters per second squared. So Ft equals, so 0.284 times 12.4 squared divided by 0.85. So the first term is 51.3739 newtons, and that's minus 0.284 times 9.81. Second term is 2.78604 newtons, for a grand total at the top. The tension is 48.588 newtons. Okay, so now at the bottom, Fg is still acting down, but this time it's away from the circle, and Ft is acting up, still towards the middle. So now, oops, I'm going to run out of room here. When we do sum of the forces is equal to mv squared over r, it'll be Ft minus Fg equals mv squared over r. So it'll become Ft is equal to mv squared over r plus mg. So the good news is these two numbers aren't changing, we're just now adding them together. So Ft will equal the 51.3739 newtons, assuming I typed it in my calculator correctly, plus the 2.786, etc. newtons. And so for part B, you should get an Ft of 5354 point something. I guess I have to do it. Plus brackets point, what was it? 284 times 9.81 times 54.15996. 1599, I guess it's really 7 newtons. Okay, so that's for part A and part B. Now part C is a little different because it wants to know what's the maximum speed that it can have if the string will break when the tension is 33.7 newtons. Well, the string is going to break at the top because that's where the most did I screw up? No, excuse me, the string is going to break at the bottom because that's where it's going to experience the most tension, because that's where gravity is working against it, not helping it. And so we do sum of the forces is equal to mv squared over r, and so it'll be Ft minus Fg is equal to mv squared over r, and this time you're solving for v. So multiply both sides by r, divide by m, so it'll be r brackets Ft minus Fg over m. So v squared is equal to 0.85 meters. Ft, they told us, was 33.7 newtons, minus the Fg was 2.78604 newtons, and then you're going to divide that by the 0.284 kilograms. And then remember to take your square root. Okay, so 33.7 minus 2.7860004 multiply by 0.85 divide by 0.284 and then take the square root and you get 9.619 meters per second. Okay, so that's number 17. Now flip the page over to 566. Sorry, just lost the iPad. There we go. And let's take a look at number 20. Number 20 says engineers design a turn on a road so that a 1,225 kilogram car could use 4,825 newtons of centripetal force while traveling around the curve at 72.5 kilometers per hour. What is the radius? In this one, it does not say that it's banked. And so you have to assume it isn't, and it's just mv squared over r. And you're looking for r. So it's going to be r is equal to mv squared over f. So r is equal to, so the mass was 1,225 kilograms. The speed was 72.5 kilometers per hour, which in meters per second is 20.138 with the 8 repeating. And that's going to get squared. And it tells us the F is 4,825 newtons. And so solve for the R. So squared times 1225 divided by 4,825. And the radius should be 102, excuse me, 0.9698 meters. Okay, number 20. Number 21 is a banked curve. Okay, so we have our car driving out of the curve. Oh, I think I just did it opposite to the way I did it in class yesterday, but hopefully you can handle that. Okay, so this is FG going down. This is FN going up. This will be FNX. This will be FNY. And it tells us the angle here is 15 degrees. And it tells us the radius is 65 meters. And it wants to know what speed can it go around. Okay? So we assume no friction. It says icy. So if we do the sum of the forces in the y direction, it's going to be 0.